Well, we have a new problem at the screen, and there are a few things I would like to explain about this problem. There is a uniform stick of length L, and that stick is this, and its length is L, and it is connected by a thread of same length, and thread is this, and its length is also equal to L. The lower end of the stick can slide without friction along the horizontal table. The table you can see here. This is the table, and the distance from the point A to the table is equal to h. H being this length, and this lies between L and 2L, and that is quite convincing in this case. It looks convincing because it must be. The stick begins to move without an initial velocity from the position shown in the figure. Find the maximum velocity of the center of the stick during its subsequent motion, and this is the problem. And we can of course use the mechanical energy conservation here, and initial energy of the system. Thread is of mass 0. That means thread is massless. Even I have assumed it. Thread is massless, and it is the stick that has got some mass, and so the initial energy of let us also assume that the mass of the stick is equal to a small m, so that the initial energy is completely potential, and it can be simply written as mg into length, mg into height. And this height, I guess, if I consider this angle as alpha, then this angle is also equal to alpha. So this length is h by 2, no doubt at all. And I get here that this height is h by 4, because center of mass of this rod lies at the midpoint of the stick. So initial potential energy is mg sine h by 4. And what about this angle alpha? This sine alpha can be written simply as h by 2l, because perpendicular by hypotenuse is sine alpha. So we can write this. But when the stick moves, its total energy at any given moment is composed of potential and kinetic energy of the rod. So let me show you a picture. At that given moment I'm talking about, this moment is any moment, any time t, and you can see the picture here. This is one end of a stick, and this is another end of a stick. And if at this moment the stick makes an angle beta with the horizontal, then this length will be certainly L sine beta, because this length is L. So this length will be L sine beta, and its potential energy at this moment can be simply written as mg L sine beta by 2. Remember, we are referring the potential energy of the rod as the potential energy of the center of mass of this stick or rod, whatever I'm using it interchangeably. And I guess there are two kinds of kinetic energy involved in this problem. One is translational kinetic energy of the rod, and another one is potential energy, translational kinetic energy and rotational kinetic energy of the stick at this moment. So using according to the law of conservation of energy, I should write that the potential energy at any arbitrary moment plus translational kinetic energy of the stick plus rotational kinetic energy of the stick, and that will be equal to the initial total mechanical energy of the rod. And so that I can write here that even the translational kinetic energy of the stick at any moment can be written simply as u naught minus u minus e1. That is u naught plus u plus e1. E1 not, this is not E1, this is basically E2. The rotational kinetic energy is written as E2, and E1 can be simply written as half mv square. If b is the speed of the rod, the speed of the center of mass of the rod at this moment, and so that, and I can find here that b can be simply given by 2 by m u naught minus u plus e2. This can be written like this, and we know for sure that we are looking for the maximum speed of the center of mass of the stick, and the speed of the center of mass of the stick will be maximum when the value of sum of u and e2, u plus e2 is minimum. ये अगर minimum होगा तो that means we can say that the velocity of center of mass of the stick will be maximum. ये ज़रूरी चीज़ है. And I know one thing for sure, that potential energy of the stick is minimum at the moment when the upper end of the stick occupies the lowest possible position. And what is the lowest possible position of the upper end? That it becomes simply vertical. That means ये जो string है, this string becomes vertical. And I simply guess, I don't know where it come, but I just simply guess that the upper end comes here and the string becomes vertical, so that the upper end of the rod is here and the lower end, the lowest end of the rod is here. Call it the position C dash, so that this length, the length of the string becomes L simply, and this total length is H, so that this length I'm talking about, it becomes H minus L. So in that case, the potential energy, the minimum potential energy of the stick becomes mg H minus L upon 2. This is the minimum potential energy of the rod when the string becomes vertical. And one more thing I would like to discuss here, because at this moment a string is in translational motion. How? Since the stick is inextensible. So stick अगर inextensible है, that means इसका ये जो end है, top end, इसकी जो velocity अभी होगी, that will be certainly something like that. Let's call it this point B. तो इस पॉइंट का नाम ही, टॉप एंड का नाम ही बी रख देते हैं. इसकी वेलोसिटी को बी मान लेते हैं, क्योंकि स्ट्रिंग तो आफ्टर ऑल वर्टिकल हो चुका है. तो इफ सिंस द स्ट्रिंग बिकम्स वर्टिकल, सो दिस एंड ऑफ द रॉड विल हैव ए हॉरिजॉन्टल वेलोसिटी, बिकॉज इट कैन नॉट मूव फर्दर, क्योंकि दिस इज द मैक्सिमम लेंथ ऑफ द स्ट्रिंग एल, एंड थ्रेड इज ऑल्सो इनएक्सटेंसिबल. सो इस एंड की वेलोसिटी हॉरिजॉन्टल हो जाएगी और इस डायरेक्शन में. And we know for sure that whatever be the angle, this, I guess it is something theta or something, I just guessed, name it. So, and rod is also inextensible. So, component of this velocity along the rod will be Vv cos theta, and so will be the velocity of this end, Vv cos theta. Because along the stick both ends should have the same velocity, because after all this is inextensible. So this the both ends should have same velocity projections along the stick only, and this is Vv cos theta. So if this angle is theta, this angle is also theta. So, and its velocity of this end is always horizontal. So you can guess here that if this angle is theta, this angle is also theta. That means this velocity, its velocity of this end, if we like to call it vc, and this vc cos theta will be equal to vv cos theta, and so that means vc equals vv. एंड ये सिर्फ इन्हीं दोनों पॉइंट्स का मामला नहीं है. इट फॉलोज दैट the velocity of all points of the string must move at this moment with the same velocity. I think I wanted to tell you that all the points of the stick should have the same velocity at this moment. All will have horizontal velocity. ऑल पॉइंट्स और सारे वेलोसिटी, सारे पॉइंट्स की वेलोसिटी का मैग्नीट्यूड फिलहाल सेम होगा. दैट मीन्स देयर इज नो रोटेशनल मोशन एट दिस मोमेंट. व्हेन द स्टिक is reaching to its maximum velocity and the string becomes vertical, that means there is no rotational motion at this moment, and that also means that E2 is equal to 0 here. And so I would like to write the maximum velocity of the stick as 2 by m u naught minus u only. U is there, this is u, that means if I clarify it more, that is u minimum, and E2 is 0 here. And so you can write the things here that it will become 2 by m u naught was simply mgh by 4 minus u minimum is mgh minus l upon 2. That's it. And if you try, you will get your velocity simply as g by 2 2l minus h, and that is the maximum velocity obtained by this stick. And that's all. Thank you very much. Last solution मैंने यही किया था. I did the same thing, but the presentation was bad because maybe I got tired. I was trying to fulfill the deadline. I don't care about any deadline. I have to be clear, so I will take care of these things. So I'm deleting the previous video and uploading this new one. Thank you for watching.